So we are starting section 1-2 in AP Statistics, and this is describing distributions with numbers. So section 1-1 was dealing with that visual data displays, graphs and whatnot, some handy dandy tables. Now we are going to be dealing with them as numbers. And so that pre-printed stuff didn't really give us the space that we needed, and I've never really, been a huge fan of it. So we're just going to run with regular paper. You guys do have, and I apologize for my arm, as you can hear me flipping through my notes, you do have space on your pre-printed notes, and it's all of that page for 1-2. So that actually, if you are printing or trying to type, go ahead. Trying to type math is not pleasant. I refuse to do it. So we are going to talk right now about measures of center. And this is where I wish we could talk and do this together, but we can't. So measures of center, we're going to focus on mean, median, and mode. So I'm going to go to mode first because it is the easiest and typically the least useful. So mode is the most common, and this is often represented in our peak. So if we were to ask, okay, how old are you guys? I'm guessing that we might have a tie between age 16 and age 17. But if there are 10 of you that are age 17 and 8 of you that are age 16, then 17 is the most common, and that would be our mode. And we just don't use it all that much. I want to talk to you guys about the median. So the median, and it's I guess you guys probably are most familiar with this because you're doing, some of you have done or are currently doing driver's ed. When you're driving down the freeway and there's that little space in between the eastbound and the westbound lanes, that's the median. So it's like the center, thus measure of center. So the median, which often is abbreviated as the lowercase m, although most of the time we just write median or MED. Mode doesn't really have an abbreviation. The median is the middle value of an ordered distribution. Distribution is just a data set. And so it's important that you put things in order. So if I were like shout out numbers 4, 3, 8, 9, 12, 15, 1. Okay, don't tell me that the middle is 9. That's the middle of the list, but it's not the middle of your ordered distribution. And I apologize. I should probably zoom in. Okay, now you can read it. But if we go from low to high, and then we're like, get rid of a little one and a big one, a little one and a big one, boom, boom, boom. There is our median. Couple things about the median. The median is what we call resistant. I think it's with an A. I'm going to put an A in there, but it'll be sloppy. So if like, oh, it was an E. Yeah, can't you tell I used that? It is resistant to extremes. So I'm going to show you what I mean by that. Now, if we have our set, and I throw in an obvious outlier, like 100, what does that do for our median? Well, as we start working our way, that was the 4 that I marked off. Oh crap, I lost my spot. 1, 100, 3, 15, 4, 12. Our median is now 8 and 9, and so we would go 8 plus 9 divided by 2, and our median changes from 8 to 8.5. So if we throw in an outlier, whether that's an upper or a lower end outlier, it's just going to shift the median slightly in the direction. It just really truly depends on how far apart the next couple of numbers are. But the median is resistant to extremes. Just like if we were to be talking about our ages, and you guys are ranging from what, 14 to maybe 19, and your median is probably going to be that 16, 17 mark. Well, you bring me into the room, put me at 44, isn't it probably just going to move the median down to the next 16-year-old? And it's really not going to change because there are so many of you packed in there. And then me with my extreme, I'm just like, oh, look to the next person to find your median. So hopefully that makes sense. The mean, also known as the average, and I need to translate my language and just start saying the mean because that's the proper mathematical term. We know how to find averages or means. We find the sum of all of our values, so all that means to add. N sub I means all the individual numbers. And then we divide by the total number of items. Okay, you guys can find an average. Add these up, divide by however many there are. You don't need me to show you how to do that. What you do need me to do is to show you how to do it on a calculator so it goes much quicker. A couple of things. The mean is not resistant to extremes or outliers, and I'm going to show you an example. So I need us to go into our calculator, clear out our data. If you guys are opening the app again, it will probably clear for you. So I need you to go into Stat, enter into Edit, go up to the top of list 1 and push Clear, and then Enter. And you guys might already have your data, gone. So I'm just going to enter this distribution 1, 3, 4. Actually, I'm going to clear it. I'm going to do something different. Sorry. I'm going to put it in not in its proper numerical order. So the way that I just rattled it off when the numbers popped into my head. 4, 3, 8. Remember, hit enter in between. 9, 12, 15, and 1. Okay. So get out of this second stat. Go over here to, second mode. I'll get there. At least this is real time. Go to Stat. Go over to Calc. Do you guys see that one variable stats? Hit 1 or hit enter. And mine is sitting and waiting. Now I have a different operating system potentially. Some of you guys might actually have something that is asking you for a list. We're going to go second L1 because that's where our data is, and hit enter. And then it's going to give you this massive amount of stuff. Well, here is your mean. The symbol for mean is X bar. Don't tell me, I don't know why I can't remember. I probably learned it in my history of math class with the 40 giant big fat books, like they were huge. I've forgotten it. So this is your mean. So our X bar is 7.43, reasonable rounding. This funky EX, if we were to add up all of our numbers, that's the 52, the sum of them. If we were to square them, it'd be 540, and I'll explain why we need that later. It's just not for today. These two are standard deviation. We'll talk about that more. N means we had 7 items in our list. Hey, look at this. Our minimum X equals 1. That was our smallest. Q3 I'll talk about. Our median is 8. Oops, Q1 and Q3 I'll talk about, and our max is 15. So right here we can find the minimum and the maximum and the median and the mean like that. We just have to type in our data. So hopefully that was pretty quick, and you didn't have to put them in order. The calculator can do it. Well, I want to go back to Stat, enter into Edit, stay in list 1, scroll down till you see the next option available, and you're like, wait a minute. So when your cursor is sitting on the last number that you've typed, it'll tell you that's the 7th number. When you arrow down, it's just saying, do you want to put another number in? We're going to put in 100, and I want to know what's going to happen to our values. Push clear. Go to Stat, go to Calc, one variable statistics, and tell it second L1. Hit enter. Now look at what just happened. If we take our distribution and include an outlier of 100, X bar, our mean, becomes 19. Our X bar had been like a little over 7. Our minimum doesn't change. Our median becomes 8.5, when before, remember, it had been an 8. and our maximum now changes to 100 because we put in this really big number. So I'm hoping that makes sense, that you guys are seeing that the mean is not resistant. The mean got pulled up in this distribution because we threw in a 100. So for example, I'm going to go over here to list 2. I'm going to go up to the top and I'm going to push clear and then enter. So let's talk about ages. Let's say that we have a couple of 15-year-olds, not a 1-year-old, a smidgen of 16-year-olds. And you're like, how many? Don't, just watch. Some 17-year-olds, an 18-year-old, and a 19-year-old. And that puts us at 16 people in our room. Okay, get out of that. Stat, calc. Now I have to tell it, clear, my screen wasn't clear. Stat, calc, one variable statistics. I'm going to do the blue second button and then the number 2, because see how that tells me L2 right there? And then I'm going to hit enter. So based on this, we were ranging from our smallest, our minimum was 15. I'm just arrowing down to see that. Our maximum was 19. Our median is 16, which makes sense based on the numbers I threw in there. That our mean is 16.5, right? Well, that really fits that distribution of what I'm predicting your ages to be. If I go into edit and I go, and I'm too lazy to scroll all the way to the bottom, so if you're wondering what I did, I went stat and then edit. If you arrow up a couple times, it takes you to the bottom. Okay, put me in there. Quit stat calc one variable statistics of list 2. Our average is now, our mean is 18. Okay, look at that. So now, technically, on average, our class can vote. But you can't, because there aren't that many of us in the room, theoretically, if we were in a room, where we are 18 and up. But look what it did to the rest of the data. It didn't change the minimum because I changed the maximum. It didn't really pull the median because it just said, oh, hey, bring the median up to the next person in line. Well, that person is also 16. So I'm going to go back into stat. I'm going to enter into edit. I'm going to go up until I hit my 44. Let's say we were in class, and right across the street from my classroom is the Wheat Chiefs, or not the Wheat Chiefs, excuse me, it is the Children Are Special daycare. And let's say I just borrow a small person from across the road. It won't be for very long. I need someone that can walk. So I'm going to say that that person is, remember when you're little, your parents said, oh, this child is 18 months old. So that would be 1.5 years. An 18-month-old highly likely can walk. So I'm going to put in 1.5. What do you think that's going to do to the mean? Let's find out. You should be making a prediction. That's still in list 2. Well, what did it do to your mean? Because remember, your mean had been 16 point something. Now it's 15. So you bring in a toddler, it's going to make you guys look a little bit younger. Whereas you bring me in, y'all look like you're over 18. But it did not pull your median. So I'm hoping you guys are catching the drift of this. We need to kind of summarize that information, but I've got a few too many pieces of paper out from my notes. So the mean is pulled by extremes. A low, and I'm going to put it in quotes, outlier, because we have to learn how to prove what an outlier is. A low outlier drops the mean. And it just kind of depends on how far away are you. So here's a really great example that most of us have probably dealt with at some point. Let's say you're doing really well on tests and quizzes. So I'm going to come over here into list 3, and I'm going to go arrow up, and I'm going to push clear. Now let's say you're doing really well. You've got an 80, you've got a 90, a 96, an 88, a 102 because you nailed it, you wrote the answer key, and then a 97. Okay. So let's do stat, calc, one variable statistics. Now I'm going to do the blue and then the 3 for list 3. Hey, your mean is 92-ish. Your median's 93, so if I was talking to your parents and I was the kid, I'd be like, hey, my median's 93 because that represents a higher value, which is more favorable. But let's say, I'm just going right back in, that we have a bad day, and it happens to the best of us. It happens to the best and the worst of us, all of us. And let's say you have a bad day, and you have like a 25 bad day, and I know all of you, like, your anxiety is going, your stomach just churns. You're like, I'm not going home today. I'm staying with my friends. What will that 25 do? Well, let's find out. L3. Okay, so your mean just dropped. Your median isn't as bad, but you know your teacher's going to talk about an average because that's how your grade's highly likely going to be calculated. So understand how that 25 being so far away is going to have a great impact. Well, then my students typically say, okay, well, what if I got like a 110 and did really well on extra credit? That feels like an outlier because it's above and beyond what I should be able to earn because I got the extra credit. But is 110 really that far away from all the other numbers? No, it's not as far as 25. So when we go to, whoops, get my fingers, oh goodness. When we go to calculate this in list 3, does it pull your mean up that high? No. The further your outlier is from your distribution, the greater the impact. If your min or max is still really close to your distribution, it's not going to pull you guys that much. And that's what frustrates people with grades, because when you do really well, okay, let's say you're sitting at 70s for your mean, for your average, for your median, and you get a 100, that's a differential of 30. Yeah, it's going to pull you up, but it's not going to pull everything up to 100. If you're sitting at 70 and you get a 5%, that's a differential of 65. That's going to drop you because that outlier is so much different than the rest of the distribution. So that's just a little something so you guys can kind of understand how means work. So along that kind of conversation, let's talk about some shapes. So I'm trying to exaggerate these a little bit. This guy right here is symmetric. This one has a right tail, so it is skewed right. This one has a left tail, so it is skewed left. Okay? So hopefully we've got that. Knowing that we have that, if it's symmetric, your median is going to be dang near the same thing as your mean. They're going to be the same. That measure of center is going to be the same. Now notice I'm not putting an equal, because what if my median is 89 and my mean is 90? Well, then they're not the same, but okay, on a number line scale, they're like virtually the same. Skewed right, your median is going to stay pretty clear to your peak, because even though we have like me at 44, it didn't really pull your median, it just pulled it to the next 16-year-old in line. And then the mean is going to move into the tail. Now I'm exaggerating this because there's no scale. It's not going to move that far, it just depends on that differential. So if you guys had your ages, and then I were to bring in my parents who are 76. Okay, let's take a quick look. So we kind of remember what it did with, that was list 2 for me. I'm going to get rid of the toddler. And you guys were age 16-ish for mean and median. If I bring in a 75-year-old, oh, I don't think I hit enter. Oh, I did. We're going to go to stat, go to calculate. That was one variable statistics in list 2. Okay, remember when I was in the group, I pulled you guys up to 18 something. One of my parents were to come in at age 75. It would pull you into almost an age 20-year-old person, average. The median still stays at 16 because we're just bouncing to the next 16-year-old, moving down that number to value line. If I were to bring in both of my parents, so go to stat, go to edit, I meant to say they were 76. So I'm going to stick with 75. Okay, that's all good. And I were to do stat, calculate one variable statistics on list 2, see what 2 of them do? 2 outliers, they're pulling even harder because there's 2 of them out there. So understand that the outlier, the further away it is, the more it's going to pull you into the tail. And so we could say that our median, in this case, is less than our mean for right skewed. On this one, I've got my congruent, like roughly the same. Skewed left, our median is going to be pretty close to the peak. I accidentally drew it a little bit off, but whatever. And then our x-bar is going to be lower. So our x-bar will be less than the median in a skewed left. Just understand that that's bringing in a smaller value. So I hope that is making some sense. I'm kind of out of room on that page. So I have some examples that I wanted to take a look at with you before we pop into spread. And I want to take a look at, not that page, page 74. Okay, so page 74, problem number 27. Quiz grades. Joey's first 14 quiz grades in a marking period. So the author of our stats book, he's awesome. I stalked him for a whole week during a training session once. He, I think, is maybe Canadian because he talks about a marking period. We would talk about like a semester or a quarter or a progress report. So here's our data. Use the formula to calculate the mean. No. Put it in your calculator. Let your calculator do it because it's a lot faster. I don't want to see you adding that stuff up. Don't waste your time. Put it in. Give me the answer. Move on. Suppose Joey has an unexcused absence for the 15th quiz and he receives a score of 0. Determine his final quiz average. Well, we'd put in a 0, and what do you guys think would happen? Well, 0 is not like his regular performance. I think the mean is going to drop. And so what property of the mean does this situation illustrate? Well, the mean is not resistant. It is impacted by extremes. Write a sentence about the effect of the 0 on Joey's quiz average. Joey's average dropped because a 0 is so much lower than the rest of his scores. What kind of plot would be best to show Joey's grade distribution? You guys totally have options. You could do a histogram. There aren't a lot of numbers in there for that histogram, so you might do a stem and leaf plot instead. Hopefully that helps. Number 29. Ooh, 29 is a good one. Number 29 is sitting over here on page 75. So baseball player salaries, and this book's old, so we'll roll with it. Suppose a Major League Baseball team has a mean yearly salary for a player at $1.2 million, and that team, oh, don't you all cheat, that team has 25 players on its active roster. What is the team's annual payroll? Okay, so couldn't we figure out how much total money the team spends on player salaries if we know the average? Couldn't we, gotta hide that, I know it's a little dark, but y'all are cheating and looking in my book. Couldn't we say $1.2 million times the 25 players? They're spending a total of $30 million because the average is 1.2 times 25. That's how that's going to work. I'm going to leave that there, you little cheaters. What would be the team's annual payroll? Got that. If you only knew the median, could you do this? No, because the median is just that middle number in the distribution, and you can't really do anything more with that because we don't know how extreme we are on either side. Okay. I hope that helps. We're going to continue because I haven't met my 40-minute mark yet, and we're going to talk some more about this section, and we're going to talk about measures of spread. So when we talk about measures of spread, range is the easiest one to address. My apologies, you couldn't see that. You still can't see it. Range is a calculation. We do the biggest minus the smallest. Now our calculator can do it, it's in there somewhere, but why bother to learn a new command when if you just go into stat, you go to calculate one variable statistics and you tell it whatever list you're in. If you scroll down, you can see your minimum and there's your maximum and subtract, right? Like, we're not going to make it any fancier or harder than that. But the range really doesn't tell us a lot of what's going on, especially when you have an outlier, because you'll have all of this data and then bonk, you can't even see it, it's over here. Well, I don't care about all that spread. I want to know what's going on over here and how did that person get over there. So one of the things that we're going to address is something called quartiles. And a 5-number summary. And a box and whisker plot. And you guys have done this before, but we get to redo it now. So when we talk about quartiles, quartiles are breaking up into 25% categories. And if you think about quarters, 1 quarter, 2, 3, 4, and you hit $1, and you stop talking about quarters, and you're like, I got $1. That's how this works. So when we start talking about quartiles, and this is where, oh, I wish we were all there, because we would organize ourselves outside in the hallway, or maybe outside if the weather is good and we don't have poisonous smoke filling our lungs. We would put ourselves from most petite, I don't want to call you out as the shortest because it's offensive, to the tallest, freakishly tallest giant in the room. Yeah, I'll call it the tallest person. And we would put them in order. And then we would work our way into the middle, right? So I'm just going to crappily graph it. Crappily is a word that we're going to use because what else can we do? So we're going to have our petite person here, and we're going to have our giant person here, and we would work our way into the middle, which is the median, and that's usually probably where I'm at. And you guys have no idea how tall anybody is in our class. I'm like 5'6" if I use my good posture. If I don't, I'm 5'4". You're like 2 inches? Yeah, I don't have good posture. So the median is the 50% mark. 50% to the left, 50% to the right. We call this Q2. 2 quarters, 50 cents. I know, I just said 50. The petite is our minimum. The giant is our maximum. Yeah, I don't have any concern about the feelings of the giant. It's always my petite ones. If we were then to look between the minimum, our petite one, and the median, typical like me, halfway in between, we would have Q1, the lower 25% mark, the 25 to the 50% mark. There you can see it. And then halfway between Q2 and the maximum is Q3. So 75% below, 25% above. And I hope that's kind of making some sense. And what this ends up being is it ends up being a 5-number summary that builds your box and your whisker plot. So we're actually going to do that. We're going to go into our calculators. I'm just going to wiggle my computer. Whoa. I didn't mean to do that. So usually silly things would happen if I was working at a whiteboard. Like, I'd try to pick up a pen and it would fly across the room. Not that I'm throwing it at anybody, but you try to uncap those pens and yeah, I guess that's the equivalent. So let's go into Stat. Let's go into Edit, and I want this distribution, and I'm going to read it off just in case you've gotten rid of it. I'm in list 1, so I'm going to repeat that. 4, 3, 8, 9, 12, 15, 1, and if you still have a 100 in there, I'm going to delete the 100. You can just delete the number. Okay, get out of that. We need to find the minimum and the maximum and the median, and then the quarters, the quartiles. Your calculator can do it for you. I love this. Go to Stat, go over to Calc, 1 variable statistics, that was L1. Hit Enter. Scroll. We have a minimum of 1, a Q1 of 3, a median of 8, a Q3 of 12, and a max of 15. Okay, we're going to sketch this. That's our 5-number summary. We've got our low, our high, we've got our middle, and we've got a couple of other breakup points. We'll look at your numbers. We're going from 1 to 15. Okay, I think we can scale that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Hey, I've got it. And that's not that bad to scale by 1. If it were from 1 to 150, I think not. I think we'd probably count by 20s maybe. That would make some sense. From 1 to 150, I would not count by 50s because that's only 3 marks and that's not definitive enough. It's not detailed enough. So we're going to put a minimum and we're going to put a point right there. And the minimum is 1. And then we're going to put a point right here and we're going to state the maximum. So notice how I've got scale and I'm getting some labels in here. I'm going to find my median, 2, 3, 4, 5, 6, 7, 8, which is right there. My Q1, oops, I didn't write median. My Q1 is at 3. And my Q3 is at 12. And you'll notice that I'm not really going to number anything else because I think it's pretty obvious that it implies that. And then we're literally going to draw a box with a line in the middle at the median. And then we've got this whisker coming out to here. And I want you guys to look at that. This is the lower 25%. Here is the lower 50 and the upper 50. This is the lower 75, the upper 25, etc. This is pretty symmetric. Look at the distance between min and Q1, the lower 25, that's 3, and then Q3 to the maximum, also 3. I didn't plan that. 3 to 8 is 5, 8 to 12 is 4. This guy is fairly symmetric. Now, something I want you guys to think about. I'm going to look at this list in here. I'm trying to figure out the best place to put it, and that's probably it. I need to prop it up. That's not working. When in doubt, use remote control for my TV. It sits outside. All right, there we go. So, how many numbers are between 1 and 3 in my distribution? 3 and the 1. There's like 2 numbers in here. And then from 3 to 8, there's the 4. In the 8, there's what, 2 in there? And then 8 to 12, there's the 9 and the 12, there's 2. And then 12 to 15, there's 1. See how symmetric that is? I've got 2 items here, 2 items here, 2 items here, and 1 item there. It's this beautiful piece of symmetry. Now, we could also do this on our graphing calculator. Remember that we're in list 1. I'm going to zoom out. And I'm going to hope it focuses. There. So our calculator can actually graph a a box and whisker plot. Go into second, y equals. Your plot might be off, so I'm going to enter into plot 1. I'm going to turn, if it's off, I'm going to come over here and I'm going to enter on. Arrow down. There are 2 box and whisker plots. Please choose the middle one. If you're like, how did you do that? You have to arrow down to the type, and then you arrow to the right to get to the middle line. Push enter, and we're going to make sure that it knows that it's list 1. Okay, when we're ready, get out. Second mode. Go to zoom 9 or zoom stat. There's your box and whisker plot. And if you hit trace, it tells you your median and your Q1 and your minimum and your Q3 and your maximum. Kind of cool, right? Okay, so there's a ton of things that we need to be able to do with this. Holy cow, a ton of things. So I want to grab a specific example. So I'm heading toward page 95, and I'll cut us off at right around 40 minutes. This is 10 minutes less than we would be if we were in class. So I'm heading toward page... I don't like that one. No, I don't like that one either. Oh, I'll get there. Patience, young ones, patience. Page 82. No wonder I'm not liking that. I'm not in the right section. It's good to have a little pause, isn't it? So we're going to do number 33 on page 82. I need to remove my remote, or I might change a channel on a TV that no one's watching. So these are what we call SHSH scores, and they are scores on a survey of study habits and attitudes for 18-year-old first-year college women. Now that is context. And then we have another group for college men. It's going to ask us to make side-by-side box plots. So let's go. Lost my calculator. Okay. So please go to Stat, enter into Edit, go up to the top of List 1, clear, go up to the top of List 2, clear, enter. I'm going to read them off, or I'm just going to type. The women's, 154, 190. I'm on page 82. I apologize, it was 109 for that value. And I'm going to start typing. Okay, before I think I'm done, I'm just going to scan through them because it's really easy to have a typo, and this is just a really smart habit to build because nobody wants their data to not match, and then it's just frustrating. What did I do wrong? If you have different values, then you probably have a typo, and that's the reality. Sorry, there's a bug in my face. I don't know if you can see it flying. Okay, now I'm going to address the 20 first-year college men. It'll be a little silent while I type. No, I haven't lost volume. I'm still typing, people. Don't judge. Okay, there's 20 of them versus the 18, so this list is going to be a little bit longer. I'm just going to scan through, make sure I don't have any typos, because I'm recording myself type something. I'm going to screw something up. Okay, get out of that. It went blurry. You're okay. Second quit. So we're going to go into second y equals. Leave plot 1 on, just like it is. If you're like, how did you get there? Enter in, make sure you hit on, arrow down once and then to the right, and select that box and whisker we want list 1. Go back into second y equals. Arrow down to plot 2. Hit enter for on. Arrow down once to type, and then to the right for that middle box and whisker. I'll tell you guys what the other one is about in my next video. But now we want list 2. Hit enter. Get out of that screen. Please go to Zoom Stat or Zoom 9. Look, we have comparable box and whisker plots. If you hit trace, it's telling you that was list 1, and you have to remember that was the women's information. And you can arrow min, Q1, median, Q3, maximum. If you arrow just down, it'll bring you to the men's information. Okay, are these symmetric? No. That little whisker and that whisker, they're not the same. These boxes are not the same. These are not symmetric. And it's not clear. Zoom in. Focus. Come on. Okay. So what does that tell us? Well, you see how these are shorter here on the left for the men, longer on the right? That's going to trail off. My prediction is that's going to be right skewed, maybe more so than the women. Take a look at the women's data. This is going to be a 45-minute video, I'm sorry, but I'm not really sorry. Take a look at the women's data compared to the men's data. Look at your median. Isn't your median, oh goodness, focus, focus. I didn't say pocus, I said focus. So the median on the women's data is almost as high as the third quartile. So that's actually really important. Half of the women have almost scored as well or better than 75% of the men. When you look at the median of the men, their 50% and lower scores were lower than the lowest 25% of the women. The women tend to have higher scores. I don't know if that's good or bad. I don't really personally care. But that's what we've got going on. 75% of the women scored higher than more than 75% of the men. Interesting. Now, why are these boxes different sizes? Because shouldn't a box and whisker plot always be like symmetric? No. So you remember how we had 18 individuals for the women? Okay, if I take 18 and I divide it by 4. Okay, 18 divided by 4 is what? 4.5-ish? So we should be seeing 4 or 5 of the women's scores in this lowest 25%. So 4 or 5 of the women's scores are between 101 and 126. 4 or 5 of the women's scores are between 126 and 138. 4 or 5 are between 138 and 154. And then 4 or 5 are between 154 and 200. That's how that works. So this is just really interesting because we can say that typically women are scoring higher than men from this group. So I hope that helps. I hope you can see some skewness, something that I'm just realizing that I didn't show you how to do. How do we actually get Q1? Q1 is the median between the median itself and the minimum. Q3 is the median between the median itself and the maximum. Okay, so a 42-minute video. We are not done with box and whisker plots. We are going to pause because that's long enough for us.